And I will start right here with Martin Bachmann. He is Director of Exploration and Production at Wintershall, with responsibilities for production companies in Germany, the Netherlands, Norway, Argentina, and Libya. He was formerly with Shell, and he has very extensive international experience across Europe, Russia, and the Middle East. Very pleased that you can be with us today. Next to him, Mr. Erik Brandsma. He is Director General of the Swedish Energy Agency. He's got extensive public sector experience at former posts including the Dutch Ministry of Environment, as well as the OECD and the UN. And he also knows the private sector, having been at both E.ON and Vattenfall. Welcome to you. Very nice that you could join us. Next to him is Mr. Ketil Fodstad. He is Senior Vice President of the Nordic Energy Department at the Norwegian electricity company Statkraft. The department deals with market operations and IT and is responsible for one of Europe's biggest hydropower portfolios, comprising facilities in Norway, Sweden, and Finland. Then we have Mr. Hafsteinn Helgason. He is Director of Corporate Business Development at Iceland's EFLA Consulting Engineers. Originally the company's Director of Environment and Safety. He has broad experience in planning and project development, including negotiation with local authorities and government. Then we come to Mr. Peter Lund, who is Professor of Engineering and Physics, Advanced Energy Systems at the Aalto University in Helsinki. He also chairs the multidisciplinary program Energy Science Initiative, and he has headed the advisory group on energy of the European Commission and coordinated Finnish R&D activities in new energy technologies. And finally, last but definitely not least, is Professor Dr. Ferdi Schüth, Managing Director at Germany's Max-Planck-Institute für Kohlenforschung, that's coal research for those who... Okay. Very good. Thanks for the tip. Okay, I won't translate it. I take it back. He also serves as Vice President of the German Research Foundation, the DFG, the DFG. His research field comprises, amongst other areas, energy, biomass conversion, crystallization, and hydrogen storage, and he's a member of the Strategic Advisory Board of the IASS. So welcome to you as well. And I would like, as we did before, to start out with one question that I just put to the whole panel, and that question would be, quite simply, where are we in terms of technology? How far can we get with the technologies that we have? And when we don't have what we need, what are the most pressing priorities in terms of where we need to go? And I'll go right down the line.
Yeah, that gives them a bit of time to think about that. Yeah, I think the most pressing, in my view, the most pressing problem which we face is actually, I think, energy efficiency. Because if I look at, and you've referred to my sort of international experience, yeah, what always sticks with me is that we're actually talking of 1 billion people in the world, 1 billion people in the world, and growing, which do not have access to electricity or a secure energy supply today. And that's going to grow further. And frankly, to meet their needs, yeah, I think we have to pull out all stops. Yeah? And it is not one against the other. It is not an either-or question. It is an and question. And I think when you talk about technology, of course, the cheapest way to provide more energy to the world is to save energy. And that's why I think this is one where we have probably across the industry, across the energy industry, we have the biggest need in the short term. Become more energy efficient. I think it has been mentioned today already that this is maybe a field where not enough is being done yet, and I do think it has great potential, because I'm much afraid that if we don't tackle that aspect of the energy supply of the world, then actually we will find it incredibly challenging to meet the 35% growth in energy consumption across the world by 2035.
And do you have a particular concrete area where you would want to see that focused, or a particular how-to about how to do that?
I think it's a bit like what we've heard the whole day already. I mean, countries are quite different across the world, yeah. And I mean, when you travel around, you experience that, yeah. You go to countries and I think you will know which ones I refer to, where in the winter the houses are heated to incredible temperatures, yeah, and you wonder whether that's really so energy efficient, yeah. At the same time, sometimes you go to countries where you actually can feel the heat coming through the windows, yeah. So I think there are horses for courses, as one nicely says in English. Yeah? So I wouldn't actually go in one specific area, but often it isn't actually big things. Yeah, you have to do. And I think a lot of subsidy which flows, say, into renewables at the moment, yeah, into partly the infrastructure, fractions of that subsidy would actually achieve an awful lot in the field of energy efficiency.
Thank you, Martin Bachmann. Erik Brandsma.
Yes, thank you. I won't fall into the trap by saying that we have all the technology that we need. I think there was somebody in the beginning of the 1900s that said everything that is to be invented is already invented. And I think that's definitely not the case. If you think back in the 60s, the 70s, Sweden was basically oil dependent. And at that point in time, if you look at the energy mix, nobody could have foreseen that by now we would have a mix of 50% hydro, 50% nuclear. So I won't try to make that same prediction for what the mix would look like in 2050. I have the confidence that we will have new solutions, that there will be new technology that will help us achieve a sustainable energy system. And then when I talk about sustainable, renewable energy system, as soon as possible, don't know 2050. But we have enough right now to start going. We need to start this process by using the technology that we have available at this point in time. And there is material available. There's technology available. Another point I think I would like to make is that one clever person once said to me that technology, a lot of the technology development is basically aimed at us not having to change our behavior. And that's where also the point comes into my that was made earlier. I think a lot of technology is maybe not aimed at bringing us the types of efficiencies, energy efficiency that we can achieve, and there's a lot to be done there. And it's all about.
Do you have a concrete example there for us?
I think. A lot of our behavior is say 90% is purely automatic, and it's the how we open doors, how we move ourselves, how we go into rooms, etc. We don't even think about this. There's enough to be done there to increase the enormous sort of amount of energy that takes, which will help us with easier gadgets, with easier technology development that may be lower fruits. And not trying to invent the big picture at once. I think that in terms of efficiency, I think our main, and in particular in Germany, I think there will be the hardest target to achieve is the energy efficiency target in Germany for 2020. And there, I think technology could be directed. Technology needs a bit of direction here and there.
Ketil.
And also I think, if I may, the connection to the whole is more than the sum of the parts. I think somebody mentioned it earlier. We need to look at it as an integrated perspective, and we're not trained to do that. We have engineers in this and engineers in that, and then we have policy responsibles for this and that. But we don't grab the whole picture. If you look at how we're going to establish a smart city or a sustainable city, you need that integrated perspective, and I think that we need to teach ourselves to look at it in a broader perspective than just these single technologies or single aspects of the system.
The systemic approach. Thank you very much. Ketil Fodstad.
Okay. I think my colleagues mentioned some very important points. Some things to add. What do we have now, you asked? And at least we have seen quite a revolution, not only in the deployment of renewables, but also in the costs. If you see the costs on solar, but also on wind, nobody would have believed this to happen, really. So that's really a success story, and I think it will continue. So that's one important driving force. It's not only about politics, it's also about actually getting the costs down, and it's happening. A second point is, of course, as this revolution is going on, we're creating a new energy system, actually. But that is, to a large part, intermittent, and it's not there all the time. So it's almost like we need two energy systems, one renewable and one backup system. And that's maybe where a big part of the challenge is. How do we best design this backup system, and how do we let the market work so that we get the most cost-efficient solutions also for the backup system? That will be a challenge as we're going forward. One of you mentioned the energy efficiency, and another mentioned the smart grids, and I think I will support that. And I think also to make the backup system work, you have to make the consumers a part of that backup system. So incentivize the demand side response. And we haven't really seen that. I think there's a large unexploited potential there.
Brief follow-up question to that. How much of the backup system difficulty is a technological problem, and how much of it is an economic and political acceptance problem? It's very hard to convince people that you ought to be paying power providers to keep plants basically offline, to keep them still. How do you do that? That's a tough political challenge.
Yes, it is. And I think I'll say like my Finnish colleague earlier, it's a very good question. But to the first part of it, I mean, technologies are there. We have, and I think the solution has to be technologically, it has to be some kind of a mixture. I mean, we have pump storage on the continent. We can build more of that. We have CCGTs. We could build OCGTs.
Do people want acronym translations here?
Yeah.
I think we're talking about
CCGT is the combined cycle gas turbines. OCGT is the open cycle gas turbines. One has higher investment costs, another has higher running costs. But these solutions should be out there competing. And we also, of course, as I've grown up almost in Norway's biggest or most important hydropower station, of course we can also provide hydro from Norway through cables. There's a large potential there also. But of course we have to compete on the same battlefield on this.
Thank you very much. Hafsteinn, Helgason.
Yes. I think we are very much in the beginning of seeing a lot of changes and a lot of development on the technical side. You know, I can give you one example. A very modern hydropower plant we put in operation in Iceland in the year of 1982. We replaced the turbines 3 years ago just to get better efficiency out of that hydropower plant. We can see hydropower plants, even older power plants, all over Europe. So the potential is huge. The technology is there. And also take a look at the wind power plant, the first generation here in Germany. Now they are for sale. You can buy them, you know, because they are not efficient enough. So the technology is in movement, and we will see a lot of changes in near future. And that will help this Energiewende. I would like to point out one thing. I think the Energiewende will not be successful without having huge connections, power line connections, from from countries like Russia. We need corridors, very clear corridors for power lines. I'm talking about DC power lines, not AC, 3,000 kilometers of length. And those will be delivering power to Germany and other countries here, and that electricity will come from hydropower plants in Russia. Maybe you don't know, but it's interesting to study how this hydropower plant business in Russia has been built up during the last 100 years. Russia started with small hydropower plants from individual people, and then in the communist period, they only huge power plants, 10,000 megawatts, 15,000 megawatts power plants. So the potential of 50 to 200 megawatt power plants is not used at all in Russia. So this is the important thing for Germany and other countries here in Europe to step away from the nuclear industry to use hydro from Russia. Another maybe something to discuss about in the near future, but we are already now discussing about, and not even discussing, we are calculating the cable from Iceland via Faroe Island and Shetland to Europe. This will be a reality within maybe 10-15 years. And the cost of this cable line is around 1.6 billion euros. That's almost the same money as you need for building up a new big coal-fired power plant. So this is also an option. And think a little bit more towards west. What country is westerly from Iceland? That is the big country Greenland. And that glacier is melting due to climate warming. That is the biggest place for hydropower plants in future for Europe as well. So we will see DC cable lines from Greenland, Iceland, Faroe Islands to Europe. And not via Shetland, we will see those cables directly coming to Germany. So we have to take power from left and right to Europe, and then you can step out of the nuclear industry as well, also in Finland.
Mr. Helgason, also follow-up question to that. We've talked a number of times today about interconnections and the need to expand them. Where do you see the bottlenecks or obstacles there? Are they of a technological nature, planning nature, investment nature, political? What would you want to see removed to make that happen more quickly?
Yeah, there are problems here in Central Europe because of the ownership of the biggest network. We are designing power lines in Norway, Sweden, and Finland. No problems. The ownership of those grid is in the hand of governmental-owned companies. So the decision is quite easy to take together with the industry. So the problem here is that the biggest part of the grid is in the hand of powerful companies. They are not willing to be flexible. It's not in their interest. I think for Germany, for instance, I studied my degree of engineering here in Germany, and as this Mauerfall was happening, I said, oh, that's a great opportunity to take the power from the offshore wind parks along the West German, East German border towards the south. But what did the Germans do? They, instead of having that as a free corridor for a power line, they built up a road for bicycles, and even the service road for the power line is there. Nobody is living there. Why not using that former border of the German countries as a beautiful corridor for the power lines, DC line, from taking the power from the wind farms in the Baltic Sea and from the North Sea towards Thüringen and to Bavaria. It's easy. It's possible to do. And why not having, they can still use the road there for bicycles, like in Iceland. Why are we in Iceland, tourists are using those ways by bicycles or motocross, It's common. It's not Icelanders doing it. The German tourists are coming up to Iceland to using our access roads for power lines on holidays. So the discussion is somehow wrong here.
Well, that was the other Wende. That was the Wende before the Energiewende. Peter Lund.
All right, so I will wend it back to the Energiewende in a sense that in my reflection, I would reflect on the Energiewende as a solution and interpret your question against the renewable energy energy efficiency status. I think what is very important to recognize when we speak about energy and where we are, that there's not a shortage of energy per se. And I think in the same way, I think somebody said once, is that the same way as the Stone Age didn't stop that we run out of stones, in the same way the Energiewende is not about that we're running out of coal. It's about larger industrial revolutions. I think that's very important to recognize. Now when we speak about energy, I think there's three important points that we need to think on is the technologies that we use for producing energy or using energy. Economics is definitely very important because energy is a commodity. This is a commodity business, so you need to always think on the price. And the third point is that energy is a very regulated business. So the political decisions are very important. So technology, economics, and the politics. That's something that you need to look in an integrated way. You can't separate those. Our colleague told about the energy efficiency. I think that's definitely for energy, any global energy scenario. Energy efficiency is about half of the problem. So it's definitely important. But I would not see so large technological innovations anymore in energy efficiency. This is a mature technology. So it is about policies, it's about bringing the technologies into use. And I would say, this may be rude to say that law is the best way to get energy efficiency into practice. That is, I think, is what much of the international experience, that you need legislation, political decisions. That's it, and the technology is there. Now, the other side of the Energiewende, the renewable energy, sustainable energy production technologies, I think, again, that the technologies are about there. And the economics starts to be in place. But it's not about takeoff. This is like an airplane on the tollway. You just have to accelerate and get a takeoff. So scaling up will be very important. Scaling up technologies, and again, I think which we have heard here today is getting the price down. You need really to focus in science and technology to get the price down, because this is a commodity business, and I think the price is extremely important, not just for the Energiewende, but for any penetration of new technologies in energy. It is about the price. The price is a very detrimental, important issue here. Now, if I would take one technology issue that needs to be elaborated more, that is definitely system integration that we heard about here in the panel and during the day. It's really putting the things together. This is like the Berlin Philharmonic Orchestra. If you don't have the conductor, it's a cacophony. And the same way, the Energiewende, if you don't have the conductor, it is a cacophony. The system doesn't work. So I think it's very important. Energy system integration is extremely important. How you kind of have the demand and supply matched. You need flexible demand. You need flexible supply. I think we heard already many examples how to do that, how to do the trick. So I'm very optimistic that, yes, you can do it. You can incorporate intermittent energy. But if you look from the eyes of the past, then you can never do that. So you need to have a fresh innovation. I think the Dong Energy here before our panel just showed how they integrate CHP, maybe, and gas with intermittent renewables. Coming from a very cold land, and I think, well, Germany is a cold land as well. 80% of your energy use in the households is actually heat. 20% is electricity. So I know that Dong is planning to actually go with their wind energy much beyond the so-called self-use limit. Self-use limit of electricity is 100% electricity certified by wind. I would think about putting 200%, 300%. And then you ask yourself, what do you do with the surplus? Well, turn it to the heat, because the heat demand is always there. And you can store heat in a very easy way. So this is just one example of a systemic innovation, which may be cheap, but you can go around the problem. So I think there are solutions, definitely. Now, as a scientist, then I need to address the question about the future. So as the technologies are there already, solutions are there, the question is there anything coming beyond the state of the art? I think now that actually science is just entering the energy. Now, energy field has been very simple. I mean, what is nuclear energy about? Well, it's about boiling water with uranium. Well, or boiling water with coal. I mean, the technology is so simple. It's about 150 years old innovation. But think of nanotechnology just changing the physics and chemistry of materials. Putting biotechnology, algae, fourth generation bioenergy, IT together. I think that's when the really big wheels to start. So this is just the beginning of a much more larger revolution. But I think, as some of the speakers said, is that Germany may be the pioneer to start, but this is not the end. I think this is really the start of a larger technological revolution, which will feed for definitely not just energy, but also jobs, green energy economy, and be a basis of a global solution. If I have time, let me just put the problem into very simple numbers. The global energy problem and climate problem is about coal and oil. Coal, 40% of emissions. Oil, 40% of the emissions. So 80% of the emissions is coal and oil. It's about mobility and it's about power. It's about our kind of a lifestyle. So I think looking at those as a kind of two specific kind of questions definitely will bring also some solutions to the problems we have here.
Thank you very much. Dr. Ferdi Schüth.
Well, you have asked three questions. Where are we now technology-wise? I would say we are there. If we weren't there, Germany couldn't dare to embark on this enterprise. We cannot implement technologies in a system such as sensitive as the energy system, which is not ripe, which is not there and available. And I mean, just to give you an example, lithium-ion batteries were developed in the 1970s. The first commercial application was 1991. Now all of us use them, and they are on the way of entering into electromobility into cars. So we are living on the research results of, let's say, the 1990s to do the Energiewende today. That doesn't mean that we don't need improvement, adaptation for the next, let's say, 15 to 20 years. But I think that the technologies which we are going to use for the next 15, 20 years is basically there. You have also asked, what do we need then? What do we have to do then? And I think then comes the really big task. The Energiewende we are doing now, phasing out nuclear energy, that's what I call the small Energiewende, die kleine Energiewende. Die große Energiewende, the big one, ends 2050, when we have 80% renewables in the electricity market. That's the big one, and that's a big challenge. And I think we need a number of different components which we are seeing on the horizon, but which is not there yet. The first one is integration of electricity and mobility. If we talk about CO2, the CO2 problem is only partly an electricity generation problem. The mobility sector emits roughly the same amount of CO2. And if we integrate that and we have a lot of renewable electricity with a low CO2 footprint, then the mobility problem is at least ameliorated with respect to CO2. So this integration needs a lot of development. And we are not there yet, definitely not. We won't get the driving ranges which we are used to nowadays with just improvement on the lithium-ion battery. We need totally new battery systems. As a side remark, there is no natural law which says that a car has to run 1,000 kilometers before it's refueled. One could maybe take a train and then switch to a transport system at the destination, which only needs driving ranges of 100 kilometers. So sometimes we need to take a step back and ask ourselves, do we directly need to transfer what we have in the future? The next one was already addressed several times. We need to solve the problem of intermittency. And the problem of intermittency is actually there are three solutions possible. One is backup capacity, the backup system. The second one is storage, and the third one is grid extension. If Europe is on a copper plate, or the whole world is on a copper plate, well, it will balance out. The really interesting thing to do is to develop the system which is most cost efficient and balances these three options: backup, storage, and grid extension. For storage, seasonal, I would say the power to gas concept, use electricity to generate hydrogen, is a viable one, but this is again something which is not there yet. The biggest electrolyzers, you need still several thousand of them to balance the peaks, and that's difficult to deploy. The grid extension is interesting, and also there we need development still. I'm not sure. One of you said we need the high voltage DC connections. Maybe we should go one step further. Nowadays, a high voltage DC is a point-to-point connection. Maybe we need an overlay grid on high voltage DC technology over the European high voltage grid, which allows low loss, long distance transport. And high voltage DC grids are definitely not in a state that they can be deployed right now. And then the last one, technology-wise, is actually not a question really of technology. We have the technology, but it's too expensive. Photovoltaics is too expensive right now. We have seen a dramatic learning curve, but I think we need to have it cheaper still, substantially cheaper. And there, organic photovoltaics or more efficiency, inorganic focusing photovoltaics would be the way to go. And the photovoltaics industry actually has a blueprint how to reach these goals over the next, let's say, decades. So these are some elements which I think are important on the scale 15, 20 years plus. But we have to do the research now because it needs to be deployed. Final point, if we go then even further, there is the kind of game-changing technologies Peter has mentioned. Right now, we produce hydrogen by an electrolyzer fed by maybe a photovoltaic system. Well, maybe we can develop a system, a photocatalytic system, which directly generates fuel from sunlight by either photocatalytic water splitting or photocatalytic CO2 hydrogenation, and fuels runs out if we shine sunlight on it. That's decades in the future, definitely. But I mean, we have to do the research now.
One brief follow-up on storage. You say 20, 30 years down the line, research needs to be done now, but can we really wait that long for it to come online? If you talk to many people in the industry, they seem to think that is the holy grail of the systemic approach and the thing that we're going to need to make those intermittent sources feasible within a larger system. So where are we on storage, and what has to happen to make that come online more quickly?
I mean, as I said, it's eventually a question of cost. You don't need any storage if you have a full grid extension or if you have a full backup system which runs on fossil. Then you don't need any storage. That on the long run would be terribly expensive. You shouldn't do it, but at least that gets us a few years further. When it comes to storage, I think one has to look, and that has been said also here on the panel, again at the systems. How do we fill the storage facility? Maybe we take all the biomass, prepare biogas from the biomass, and feed the biogas into a storage facility to supplement the natural gas and have a methane seasonal storage facility. Maybe we use surplus electricity, generate hydrogen, store hydrogen in subterraneous caverns. Also a possibility, but for that we need better electrolyzers. We are not there with the electrolyzers. It's not cost competitive right now. Stored kilowatt hour is too expensive. Again, it always comes down to a question of cost. We have to bring costs down here.
Erik Brandsma, you had a comment?
Just linking it to this, I don't think it's only a matter of cost, and it all depends on the scale you look at this. I mean, you're right, those three options in terms of the intermittency issues are the three solutions. But it depends on whether you look at it in terms of a national issue or whether you look at it at an integrated European perspective. And then you have to have a combination of those three, of course. And then you can, of course, use storage capacity in the Nordic way, if we talk about the Nordic way, where you would be able to store the intermittence instead of selling it too cheap to the French grid, where the German consumer isn't benefiting at all.
I couldn't agree more.
Look at it as a European perspective, that's all I'm saying.
No, I couldn't agree more. We basically will probably have all three different components, and well, fractions we can discuss now in the future, and I wouldn't want to make a prediction. We will need all three components in a future system. I totally agree.
Martin Bachmann put his hand up first, and then we'll go to you.
Yeah, maybe just at the risk of spoiling the party. Yeah? I mean, as being the one who has to worry about producing oil and gas. I mean, what I worry about, of course, is I need to invest now for the next 25 years. So I look typically, when I tell you numbers of energy growth, oil, gas, renewable energies, I look at 2035, because that's the investment horizon I'm in. And that's when doability comes into the picture. Yeah? I mean, I thought it was very nice this morning, the example of the huge brick of a mobile phone in the 90s, and now we have the nice little small ones. But of course, let's remember, nobody said in 1990, that's a great idea, and now let's cut all the copper wires which bring telephone signals across, and boy, will these shrink very quickly, these mobile phones. Yeah? I mean, that's clearly what not has happened. Yeah? And I think that's why we need to remember on the investment cycle we are. And I think that's when we talk about natural gas, for example, as the ideal brother, if you want, to the renewables, yeah, which actually bring that flexibility we need. And it does not make any sense to burn coal because we're subsidizing offshore wind so heavily that we can afford to burn coal, with the effect actually that greenhouse gas emissions go up as a result. That cannot be right, frankly. And I think that needs a rethink. And that needs a rethink along the doable and the affordable, and not along the desirable. And I mean, what I would sometimes term a sort of a rich people's debate, as we sometimes have around this problem. And that's why I think, I mean, when we talk about, and you've sort of nicely put the coal and the oil at the end of the debate here, yeah? When we sometimes have quite interesting debates on what might be decades away, I do think there is a role to play in the international and in the global energy supply and in the global wealth creation for fossil fuels, and in particular natural gas, for many years to come.
Thank you very much. So Peter Lund had a comment, Mr. Helgason had a comment, and I also have a question out here, so I'll ask everybody to keep their
I would just like to comment the energy storage question. Very often we perceive that we need a storage in order to solve the intermittency question. But I think, as Ferdi point out, there's different approaches to the intermittency question and on integrating the new technologies. And storage is one of those, but there's a lot of systemic kind of approaches. And I think from the Nordic countries, definitely we can give an example of the Nordic electricity market, where let's say the hydropower is in a common pool. So each of the countries don't have a separate hydropower, but it's part of the market. So if you need some backup power, you just kind of phone the exchange and you get the power there. So I think systemic kind of innovations, and the markets innovate much more than we perceive. It's not just the scientists that innovate, but having the market conditions correct, I think the markets may find solutions. I think the Nordic Nord Pole is an example where we could integrate a lot of wind power if the grid extension is just enough there, and the storage would not be a problem. Of course, if we have a super storage, that's good, but I think that's not a prerequisite to go for Energiewende.
Mm-hmm. Thank you very much. Mr. Helgason?
Yes, just to talk a little bit about the offshore wind. You know, we are not specialists in that, but 4 years ago I had the opportunity to discuss that issue with one of the managers in one of the leading power companies here in Germany, and he told me that that time that the cost behind each megawatt will be around 2.8 million euros. Recently I had the opportunity to meet that same person, and he told me then, okay, the figure is now almost 4 million euros per megawatt. So for him and his company, it must be very, very big problem to face this fact, you know, that the cost is now almost by 4 million euros instead of 2.8 million euros few years during the planning phase. So what is happening? What is the, you know, I would like to ask somebody, if somebody could answer that question, why is this happening in Germany with all those engineers, all this know-how? How could this happen?
Ferdi, Schüth wanted to answer something else, I think, but now you must answer that one also,
no, definitely
please.
That. I wouldn't dare to answer that one. Definitely not.
Good question. Yeah.
It's a great question, yes. No, I wanted to just briefly comment on Martin Bachmann's deliberations on natural gas to show what kind of game-changing technologies may come further in the future. You don't have to necessarily burn the natural gas. There is research going on amongst other places in IISS to split natural gas into carbon and hydrogen. You could burn the hydrogen totally cleanly and put the carbon away, which is an alternative to CCS, because you don't have to store a gas, you store a solid, which is much easier, and you retain 50% of the energy content of the natural gas. So if you take a step back, there are sometimes options which you don't obviously, which you don't perceive as obvious solutions, but which could be very interesting nevertheless on the long run.
Does one of you want to answer Mr. Helgason's question?
Definitely not, but oh, as a professor, you can always, answer another question. You can, that's the way you go. Yes, as a politician, as a professor, maybe it is both the same kind of a feature. Now just coming back to one of the kind of points that Dr. Bachmann took up was energy efficiency, and I think this is very important in the Energiewende in the sense that we need to think where the energy comes from. And typically, if you take a global view, about 2/3 of all our energy use is in cities, in the urban environment. And through the urbanization, about 80% of all energy by 2040 is from urban environment. So I think the big challenge is really not just the energy efficiency, but also bring the technology. If we can bring the technologies, supply to the cities, where you could use waste for bioenergy or solar. I mean, this is the solution. So we need to think where the energy is used. Mm-hmm. And I think the Nordic case is not a good case in the sense that we're not that densely populated. But take from Germany or Central Europe, Africa, Asia. That's where the population megacities are. And I think the solutions that we look for should address more that kind of a point as well.
Thank you. Ketil Fodstad.
I think I'd like to throw in a couple of new elements. Since we're talking about technology, there are some technologies we haven't discussed much, which are actually old ones, but the amount of them will be very decisive for what happens. We have discussed CCS and CCU, but we don't know in which direction this goes. But that will really decide a large part of the energy mix. Another point is nuclear. We see it's like Europe is sort of standing on some kind of a tipping point. What happens to nuclear? We've seen the decision in Germany, but what will happen in the other countries? What will happen in France, Finland, Sweden? We could see some very important decisions there that really will influence the energy mix. I don't know which way it goes, but it's really important. It's like in Statkraft, we do a lot of analysis work, trying to analyze the Nordic and the European market. And at least specifically for the Nordic market, what the Swedes and the Finns are doing on nuclear really decides a lot of the energy balance. We predict a large oversupply in the Nordics, but if you change the course on nuclear, the picture is very different.
Thank you. I have a question up here. Paul Hawkins.
Paul Hawkins, European Energy Review. Two very short comments followed by two short questions. Firstly, one of the presentations talked about the subsidies going to renewable energies, but the presenter didn't talk about the subsidies that have gone to and continue to go to fossil fuels, which far outstrip that which goes to renewable energies at any time during the history of subsidies, including today. You even just take for nuclear, just take for coal, it's more than renewables alone, much less adding them together. And for the panel, then, I mean, what about eliminating the subsidies for fossil fuels? Wouldn't that be a game changer? Second question is, I mean, almost every one of you, when we're talking about these technologies, you say we're already there. I mean, basically, we've got what we need to conduct the Energiewende. That seems actually very different from what Minister Altmaier said, who said, really, we've got to start slowing things down. We don't want to go too fast. We don't want to use technology that's going to be outdated further down the line. Are you in agreement with him that Germany is going too fast?
Go ahead, Peter Lund.
Yeah, the question about subsidies, I think the subsidies for fossil fuel is about 400 billion a year. So that's much more than it goes to for the renewables. I think in case of renewables, we should not speak about subsidies, but it's really learning investments to get the new technologies on the market. So subsidies typically support something old. I think the question of removing the subsidies would be extremely important, because it means that then you would also price the energy in many countries in a correct way. Take, for instance, the example of Saudi Arabia, which is the largest oil producer. Very cheap oil means that everything what they're doing in energy is oil-based. So Saudi Arabia will, in 20 years, they will not have a droplet of oil to export, because they use all their oil domestically. And that would be very catastrophic for many countries. The same goes for Russia. So removing subsidies from fossil fuels is really to get the correct pricing mechanism. And then you start to invest in energy efficiency. Then you automatically will look at Saudi Arabia, look on solar, etc. So I think this is a very important question, is the sense that that would change for sure much of the pace of the development.
Would you take Klaus Töpfer first? Yeah. Klaus Töpfer.
Yes, thank you very much. I would be to the utmost interested what's your consideration with regard to the other way to harvest sun. We are always discussing photovoltaic. Nobody until now mentioned CSP, concentrated solar power. And we know that this is quite intensively looked at in the Arabic world. I just come back from Qatar, where they want, of course, to substitute the desalination structure, not using their fossil fuels, but to using their sun. And they are asking for the transportation of the harvested sun, for example, via hydrogen and others. So I would be extremely interested to learn a little bit about your ideas in this field. And one additional topic, it is the perspective that the capital cost in energy is increasing and the fuel cost is decreasing. If this is happening, energy efficiency has a totally other structure, because it is not paying back a lot. Mm-hmm. If the fuel is in solar and wind, it is zero. We have no marginal cost. So you have the cost and the fixed cost. I would like to learn a little bit in this direction as well. What are the consequences of this?
I'll let Ferdi Schüth take the first one, and who would like to have the second?
Yeah, first, maybe one comment to the question, why is it so slow? Why are we slowing down? I don't think this is a technological problem. It's an implementation problem where we need the right laws implemented and really working, where we need the mindset of the population changed in a way that allows quicker processes. So I would consider this mainly as implementation problems, not as technology problems. I do think the technology is there. And I do think that one can make choices without getting into a lock-in situation. That's for that question or comment. Then I take the concentrating solar power. That's perfectly correct. It's an alternative technology we have. The main difference is concentrating solar power needs direct radiation, so it's good for areas like the Sahara, southern Spain, where they have a lot of direct radiation. Here in middle northern Europe, it's probably better to work with PV. But even in the southern countries of Europe and northern Africa, it's right now not clear what the cheapest solution eventually would be. When the Desert Tech initiative was thought out like 10 years ago, maybe even longer ago, concentrating solar power was the cheaper solution compared to photovoltaics. But the learning curve of photovoltaics was much quicker, and right now I think nobody would place a bet. Well, people would place a bet. People are always betting, but I wouldn't place a bet on the technology which will eventually win out with respect to cost. Right now they are probably rather on par, maybe with slight advantage for photovoltaics, but this may change. But it's a viable option, and both. Well, it has the baseload capacity because you can easily, like someone said, heat is easy to store. You could easily integrate a storage system. That's again then the question, how well is the grid infrastructure and everything, whether that's sufficiently advantageous to compete with a cheaper photovoltaics. So it comes again down to a systems question, I would say.
Thank you. Erik, Brandsma, did you want to speak to the CapEx, OpEx question from Mr.
No,
Turkov?
just a reaction on then, just briefly. I mean, let's not forget that this is a system that's in transition, and it will take time. But you have to make sure that you do not sort of take everything out of balance, because then will go too fast, and there's established forces that need to be taken care of. That's I think my answer to the subsidies question. I think everybody's aware of that, and it also answers a bit, I think, the point that Minister Altmaier made. We shouldn't go too fast. I think one of the things that you said about the Energiewende, it's a good thing because everybody can take part in it, but then you also have to make sure that everybody's with you, and that, I think, was my interpretation. It's not a technology issue that we're going too fast with the implementation of the technology. You have to make sure that you bring your stakeholders and your interested parties with you and don't go too fast. That was my issues. And I think you made a very good point on the energy efficiency. I mean, this is probably one of the reasons why this is the most difficult target to achieve in Germany and anywhere else in Europe.
Peter Lund had a comment.
On the energy efficiency, again, if you have much intermittent, let's say fuel-less electricity production, it means that the price of electricity comes down. Most of the time it's zero. And the question is what's the case for energy efficiency if you don't get any revenues? I think that there's the caveat in the sense that if the price of electricity comes down, that the volatility goes up. So most likely the energy efficiency comes through DSM, Demand Side Management Services. So actually there could be a market, because you need to actually regulate the demand side. But basically there's a flaw in the system, in the market system. If you think on the much intermittent renewable, even the renewables don't get the investment back. So I think when we go to Energiewende, you need to change the institutional system. The law, legislation need to be updated so that you can foster investment. So I think that's something that we for sure will look forward from Germany, that you need to think maybe on legislation as well. In the case of energy efficiency, it seems that imposing a law is the best case, unfortunately, in a way. Yeah.
Thank you. Ketil Fodstad, you wanted to add?
Yes, add on what Peter said, saying that we might get lower prices but higher volatility. And then there's a question, high volatility, is that a problem or an opportunity for the consumers? Because first response would probably be, it's a problem. But on the other side, if we really want demand side response, then we need the volatility. We need the market signal to the consumer.
Thank you. Is it Hermela?
Thank you. Just a short comment, because in Finland we are thinking a lot about this and speaking a lot about this. What kind of volatility is accepted by the society? Private consumers, industrial consumers, and so ever. And we don't know the answer. We are guessing. But very often I hear my colleagues saying, and perhaps I do say too, so that we have to see that the volatility does not go up to an unacceptably high level. Where it is, I don't know.
Thank you very much. Other questions? Okay.
Yeah, it would be interesting to hear what you have to say. I mean, if we make energy efficiency measures, which are obviously often very cost efficient, there will be money left. Say we sell our highly fuel consumption car we trade it in for a fuel efficient one. As a customer, we get more money. And so the question is, what will we do with those money? Maybe we fly to a long distance charter trip or something like that. So I wonder if you have any reflections on this sort of, say, indirect rebound effect. How could that be handled? We all should go to the opera or theater or something like that. But then those who sing, they will buy big cars, perhaps.
Do I have a response, Peter Lund?
Well, some economists would say that the rebound effects are so large that all the benefits are lost. However, empirical studies show that in countries like Germany, the rebound is not 100%, that most of the money that's saved is going to, let's say, intangible type of investments. You go for theater, for health, or for something like that. So I think the case may be other in let's say high-level countries, but I would say most European countries you would not see that kind of rebound that which let's say a economist may claim. I think that's what I think IEA and other institutions have shown.
Thank you. I have a question here in the second row.
Thank you very much. I'm Tuuli Kaskinen from Demos Helsinki think tank. And actually, Erik Brandsma made a very interesting point in the beginning, saying it's not only supply, but it's demand where the technology appears. And we have been, there has been some ideas dealing with that coming up, but actually probably not that many. I would like to hear some of your ideas of where on the demand side the technology will be bursting next. Is it like iPhones that tell us when to put our washing machines on, or what else could it be?
Ferdi Schüth has some ideas.
Well, first of all, there was a study of our German DINA which said that demand-side management won't have much of an effect before, let's say, 2020. So for the next years, it's going to be difficult. It will start with the big industrial users. So big chemical plants which run electrolysis or something like that, they will shut down when the electricity goes too expensive. I also think that a pretty rapid development will go along with electromobility, because that's a big chunk of electricity you need to charge up a car. And so these big consumers, they will be the first ones. Eventually, I don't know in how many years, it may actually happen like you said. Your iPhone tells you switch on your washing machine or switch off your iPhone because it's too expensive.
I think in case of energy efficiency, it's very often it's incremental steps, many incremental steps, and that makes a big lot. I think just lighting about 15% of all electricity goes to lighting. So if you would change all the incandescent bulbs that you have in developing countries into LED lamps, you would save 15%, which is the all hydro or all nuclear. So it just shows also that the kind of policies, how to get these technologies which are there already to each household are very important. I would say policies would be more important than technologies when we speak about energy efficiency, though there are definitely scope for technology improvements.
Thank you. Any other? Erik Brandsma, and then we'll come to this
just
question.
short. I think most of it is said, and I was going to say that the lighting example is an excellent one. I think small things. Now in Sweden, I'm able to get my energy bill by the hour, not by the day or the month, or even by an average over the year. And those kinds of things, they make a huge difference, and they will help us. So also creating much more awareness of this, it becomes much more interesting to charge my electrical car at 12 o'clock at night and put the washing machine on and so on. And there's great improvements to be made there. Then I also think that over the longer term, coming back to my earlier point, that we need to look at it in a broader perspective. If we plan our cities, you mentioned how much energy use was going to be in the cities in the future. If we plan our cities in a better way, then we are also able to do something about the mobility issue, because that's where I think the huge challenge lies for the future.
Thank you. I have a question up here.
Yes, one comment and one question. My name is Esa Hyvärinen. I come from a company called Fortum in Finland. About this flexible consumption, there is already a product. We launched a product this autumn called Smart, with the help of which electricity consumers, household consumers, for example, those who are heating with electricity, they can allocate their power consumption to the hour where the price is the lowest. The price is following the power exchange price, and it's always determined for the next day. So the day before, our product automatically allocates the biggest heating cost for the hour where the price is the lowest, i.e. when the demand is the lowest. So it's coming already for the households as well. It's a smart product. It's called Smart. My question is related to, we have heard a lot of talk about policies, legislation, subsidies, etc. What is the role of markets? What is the role of market forces in 2020 and beyond? We have nothing against, or nobody has nothing against, good legislation, but how to exploit legislations and policies in order to exploit market forces?
Thank you. Who would like to address that? Erik Brandsma, please.
Yeah, I mean, just as an example, I mean, if you in Sweden the system, and now also combined with Norway actually, if you want to support and stimulate renewables, you use the market forces. So you develop an instrument that is technology neutral, and create the demand through the quota obligation that all the electricity suppliers needs to have up to a certain percentage, cover their electricity sales by a certificate, and that put into the market then determines also the development of the price that possible investors can get. So I sort of answered to your question, and it's happening, and it's, I think, the most promising mechanism, the market mechanism to develop the renewables, and if you do it technology neutral, and that could continue on other elements also.
Lund, please.
If I may very, very shortly comment, I think it's important to recognize that policies are about framework and vision, but you need the market mechanisms to make things real. So I think market mechanisms definitely are important, and I think here it's important to recognize, let's say, smart mechanism. Like competition is smart, and we know that procurement is smart. So going for mechanisms which are catalytic, you don't need much money, and you may have a very large kind of benefit. Feed-in tariff, which is good, and it's a very fast mechanism, is typically a volumetric instrument. So you need pretty much money to get the effect. So maybe in the future we need this kind of catalytic, in a way, the market mechanism where you really use the market forces. And in that sense, you may save maybe a few times the money instead of going for a very kind of strong volume instrument. So I think market forces are important, and there's still much to do in the policy side, definitely here as well.
Hafsteinn, Helgason.
Yes, before we leave this room, I would very much like to inform you, if you don't know it already, that under here we have deep geothermal energy. And indeed, from even Denmark down to Krakow in Poland, we have huge potential of geothermal energy, not so very deep. You know, we have to drill down to 1.68 kilometer maybe in the area of Schwerin, and we could get up to 100 degrees, 120 degrees hot water up, and that along this whole line. But in Schwerin and up there, they are firing gas to heating up water for space heating. So this is wrong. So I think I'm coming from Iceland. We have the biggest space heating, facility on Earth in Reykjavik. Why are the Germans not using the geothermal hot water more than they do today? I know one thing. I was recently in Poland, and I know also from the German side. I have been discussing that a little bit with the authorities. I know that the drilling cost here in Germany, as well as in Poland, is more than twice as expensive like in Iceland, even up to 3 times more expensive in Poland for a well of 2 kilometers depth. So I raised the question, why is this? Is it because of lack of competitiveness, or what is going on? Part of the answer is maybe the following. The drilling companies in Europe, from Holland to Poland, they are mostly drilling for oil and gas companies, searching for oil and gas. And this industry...
You can have as many drilling rigs in Europe as you want. There are stacked drilling rigs around in Europe looking for work. So this is not the issue of that there isn't enough drilling rigs because they're all drilling for oil.
The rigs are there. The price is so high.
No, but the rigs, the drilling companies are knocking on our door asking whether we don't have more wells for them to drill. So that's not driving the prices.
You know, we have in Poland alone, we have 9,000 wells. Just a few of those are giving gas. In many cases, they have found hot water and they close the wells. And those wells are not used at all. So this is also the case in North Germany. So I know only one thing. I've been discussing with one of the directors of the drilling company here in Germany, and the situation is the following. The oil and gas industry is able to pay higher prices for drilling than the geothermal business is doing. So we have to find a way. It's not a question about the technology. It's a question about, talking together and find a way to reduce the prices. We managed to do that on a project in Turkey. They started with high prices, then we said, okay, let's talk about it. So many meters of steel, this much of mud, and this, so many man hours, and then we calculated and we managed to lower the price dramatically. So I think there is a lot of work unfinished here in Germany to raise up space heating by using geothermal sources. You have here already outside.
Klaus-Töpfer, did you want to add something there, or you? Small? Yes?
No, it is without saying that we didn't invest a lot of money in research in geothermal. That's true. It's changing now. We are starting again. There are historical reasons for this and others. I lived 8 years in Kenya, and you know that the Rift Valley is the place for geothermal. We have there only in Kenya 3 commercially handled geothermal power stations. And I believe that the link to the oil industry is the other way around. For a long time, we were convinced we have not to invest any science in this because we can only use what they are doing. And this is a mistake. There's really a mistake. We have to develop the technology. If you see the water, the contamination of the water, and so on, that makes the things a little bit more difficult. I can give you the same information from Kenya once more. But be sure, yes, we want to do it. And last sentence, we were always convinced that mainly Japan is investing in geothermal because they had a lot of good reasons. But they didn't invest in this at all. Now they start as well. So I believe that we will have a revival of geothermal around the world. You know that the experience of the city of Baal was not the best for promoting geothermal. They produced an earthquake in Baal. In those days, they are not extremely convinced that geothermal is the best option.
Thank you very much. Martin Bachmann.
Yeah, I actually wanted to answer to the market question. Yeah, and I think I'm not going to say it's an interesting question because it is an interesting question actually, and I think what we forget, and I think it's maybe not come out a lot today, the world of energy supply is an extremely global energy. It's actually not particularly regional. It can have regional aspects which have to do sometimes with geography, can have to do with geology, can have to do with meteorology. But in the end, it's an intensely global industry. And given that it is global, it has enormous impacts on the global markets because it does impact global competitiveness of enterprises. And that's why I think it's nice to talk about the Nordic way and the European way. But in the end, if we want to tackle greenhouse gas emissions, I think it has to be a global approach because it is a global market within which that is taking place.
Ladies and gentlemen, you couldn't ask for better last words. I think that is the absolutely best possible closing to a very, very interesting discussion. May I say a warm thanks to all of our panelists for provoking a great deal of thought, which we can go on to discuss in just a bit at the reception. So many thanks to all of you.